So here, let me call the speed of this first boat to be v sub 1, and it takes 2 hours to travel downstream. So in this case, it will be assisted by the stream, so the speed will be v1 plus s, and I'm calling s as the speed of the stream in kilometers per hour. And then as it goes back upstream, the speed would be v1 minus s, and the boat will take 3 hours. So it's covering the same distance, so our condition is whatever the distance d is between the port A and B will be v1 plus s, speed times time, and that's equal to v1 minus s times 3. So we can use this equation to find the speed in terms of the speed of the river. So I will distribute that here, 2s, 3v1 minus 3s, then combine these two, move that over here. So v sub 1 is 5s. And that means that I can write the distance as v1 plus s, so that would be 6s times the 2 hours. So that's the distance between the two ports in terms of the speed of the river itself. Now we have to talk about the second boat, and I'll call its speed to be v sub 2, and it gives you the total time to be 6 hours. And I'll assign the times to be t1 and t2. T1 is the time it takes to go from B to port A and return to port B. And the question is the time it takes the slower one. So we're really just looking for t1. I'll say that's from A to B. And in this case, this is traveling downstream, so this would be v2 plus s times t sub 1, and that's also going to be equal to v2 minus s is equal times t2. And the other condition I have that the total times add up to 6. So my interest is in t sub 1, so I'll really just try to eliminate t2. So t2 is v2 plus s, t1 over that, and I can substitute that here. Just have to do this algebra here. So I just moved it. I mean, this is that term. So the numerator becomes t1 plus v2 t1 minus st1. I'm kind of doing the algebra, meaning combining these fractions and also cross multiplying at the same time. So this becomes 2 v sub 2 t1. These two drop out, and 6 v2 minus s. So that becomes 3. So I'll leave this here. And I also know that the distance, which we found in terms of the stream speed, and I can equate it to either one of these. Either that, I'll do that one because that relates t1. And that means that I can eliminate v sub 2, or write v sub 2 in terms of s. So that would be t1 minus s, so that's v sub 2. So I can substitute that here. Essentially, I'll end up with an equation that has only t sub 1, which is what I'm interested in. And then I'm going to multiply both sides by t sub 1. And you'll also notice that the s drops out. That just becomes 1. And that's going to become minus 2. So a little bit messy here, but actually let me write down the intermediate step without the s. So multiplying both sides by t sub 1. That would become that, and 12 minus 2 t1. So we'll have this quadratic. Minus t1 squared, 36 minus 6 t sub 1 minus 18 t1 plus 36 equal to 0. So now I know the answers are in radicals, so I'm not going to attempt to factor this and just directly use the quadratic formula. So 18, that way I don't have to think too much. B squared minus 4 AC 36 over 2, and then 18 plus minus, and I can see that I can factor out an 18. So that would be 18 minus 4 times 2. So that's going to become square root of 10 over 2. So that becomes 9 plus or minus. This would be 3 root 2. And then I have a root 10 here. And I still have a 2 here. And since root 10 would be root 2 times root 5, and these two root 2's will give me a 2, so that gets knocked out, and I end up with 9 plus minus 3 root 5. Now note the total time is 6 hours, so I can ignore the 9 plus value because that would exceed 6. So the answer is 9 minus 3 root 5, and if we factor, we end up with that, which matches with answer choice C. So yeah, quite a bit of work. I mean, this is a hard question. I mean, this is how I did it. Perhaps there is a more efficient way of doing it, and you should try different ways of doing it, because in the end, you want to take an approach that you're comfortable with. So to summarize, the answer is C.